At Xerox PARC, we've been investigating ways to make the gestures we use to interact with our computers more like the gestures we use to interact with everything else. For example, consider the task of navigating through an ordered list. Here we see a real-world version of this task. The list is contained in a physical device known as a Rolodex. The user scrolls through the list by tilting the device forwards or backwards. When the list is positioned correctly, the user can grab the item they wish to examine. The physical actions are hence tilting and grabbing. We augmented a computer so that it supports similar physical gestures to accomplish a similar task. Here we see a popular handheld computer, a Palm Pilot. On the display, you can see a few items from an ordered list. The user scrolls through the list, not by poking at buttons, but by tilting the device forwards or backwards. The more severe the tilt, the faster the rate of scroll. The user grabs the item by exerting a slight squeezing pressure on the side of the device. For our second task, we choose the display of sequential pages of text. Here we see a real-world version of this task. The user goes to the next page by making a flicking gesture from right to left on the upper right part of the page, and to the previous page by making the gesture from left to right on the upper left part of the page. We augmented a computer so it supports similar physical gestures to accomplish a similar task. Here we see a representative pen computer, a Mutu. On the display, you see a single page of text selected from a sequence of pages. The user goes to the next page by making a flicking gesture from right to left on the upper right part of the page, and to the previous page by making the gesture from left to right. These techniques can augment, not just mimic, real-world tasks. Here we see two users, one right-handed and one left-handed, reading and annotating some text. The angles with which they view the text, the areas of the page which are within quick reach of the annotating hand, and other attributes are all very different. The same applies to users holding small computers. Yet, traditionally, such computers have been insensitive to this distinction. We augmented a popular handheld computer, a Casio Cassiopeia, so that it could detect handedness and alter its user interface accordingly. When the right-handed user holds the device, the text shifts to the left to give the user a big annotation margin close to their pen. When the left-handed user holds the device, the text shifts the other way.